Good afternoon. Good afternoon, class. Math 200, DMCC Spring 2012. Special good afternoon to Professor Agu. I'm going to make a presentation about my floor plan. Here is the floor plan of my apartment. You can see here 7 different regions: dining area, living area, closet, kitchen, bedroom 1, bathroom, and bedroom 2. Now I use 3 different colors here. The chromatic number of this plan is 3, because I color neighboring regions using different colors. Dining area is neighbor to the living room. There's a line segment actually connecting them, so I use different colors. But because dining area and the bedroom 1 are not neighboring regions, they are connected only by a dot, I can use the same color for them. But in the graph I'm going to make to represent this floor plan, there's not going to be a connection between the dining area and the bedroom, because they're not neighboring regions, although they have the same colors here. Now just hang on a second. Here's my graph. The graph representing my floor plan is here. So, like in my floor plan, the graph has 7 vertices. Now I label them V1, V2, V3, V4, V5, V6, V7. Now, the vertices are connected by edges. Some vertices have more than 2 edges. V2 has 5 edges. Now, the chromatic number of this graph is 3. The number of vertices is 7. The number of edges is 10. But the number of Euler paths is 0. Now, why is that? Because in this graph, there's more than 2 vertices that have an odd number of edges attached to them. You can see here V6 has 3 edges. 1, 2, 3. V5 here has 3 edges too. 1, 2, 3 edge. V4 has 3 edges also. 1, 2, 3. Even V2 here, 5 edges. 1, 2, 3, 4, 5. So you have more than 2 vertices that have an odd number of edges attached to them. So they say that this graph is not traversable. Now, the story of the graph theory goes like this. In the city that we now call Kaliningrad in Russia, in the 18th century, there was 7 bridges in that city, and people love to visit all the 7 bridges, but they would have to travel back and forth along the same edge they previously used in order to visit all the 7 bridges. So the mayor of the city tried to find a solution. He tried to find an efficient way in which you could visit all the 7 bridges, but using only one pathway, only once. Once you travel one pathway, he didn't want to go back to the same pathway. He wanted to go from here to another one and to another one. Now, bear in mind that this configuration here is not the same configuration of the 7 bridges of the Kaliningrad story. So, they wrote a letter to Euler, who is a great mathematician of the 18th century, of all time anyway. So Euler, in order to find a solution to that problem, he actually developed the theory what we call today graph theory. He represented the land masses by the vertices that we have, and then the connection between the land masses, he replaced them by edges in order to solve the problem. he came up with a understanding that once you have more than two vertices with an odd number of edges, the graph will not be traversable. There's no way you can do an Euler path, an efficient path in which you go using one edge once at a time and using all the edges. So as the story here also in my graph, Euler path here is 0. So that's what I wanted to present today. And thanks again for everyone watching and listening. Special thanks to Professor Agiu. And bye-bye.